Hello guys, we are solving another problem here, and in this problem we are given it seems like a root of a binary tree node, and we want to return a list in pre-order traversal. Now pre-order traversal, what does that mean? Traversal is simply traveling through the tree, right? We're given a binary tree and we want to travel different nodes in a binary tree, but in a particular order, which is called pre-order. Now, pre-order traversal, if you Google that, then it's simply traveling the uh, nodes in a particular order, and that starts with root node, then left subtree, then the right subtree. That's the order we have to follow. So basically, we if we solve this problem in recursive way, it's pretty simple. In fact, I've written the solution. Let me just copy and paste it. So you can see the solution is very short. Like if the root is none, which means there we are uh, at the at the leaf node, or there is no further nodes in a binary tree, then we want to return empty list because there are no elements there. But if there are, then what we want to do is print the root node first, just like what we have searched. Then we have to go to the left subtree, and that's what we are doing here. Like we are recursively calling the same pre-order traversal, and we have assigned the left subtree here. And after I am done with the left part of the subtree, I'm going to go to the right of subtree, recursively calling the same function, and I'm adding it because all these functions are returning list, and if we add list, we are just simply concatenating the values, and this should generate all the right values. This is a valid solution. Yes, it passes all the test cases, but the thing is, if you look down, yeah, it solves the problem, yes, for sure. But if you look down this, you can see the follow-up that says the recursive solution is trivial. It's pretty easy, right? Could you do it iteratively? And that's where the trick lies. So I've also written the solution that solves this problem iteratively. Let me copy and paste it on the screen. So in this solution, what I've done is, if the root is none, then obviously we want to return empty list. And then if that's not the case, then I am assigning or initializing a list called answer that holds the values that we want to return. And then we also have a stack, and stack I've initialized it with the root node inside a list, and I'm running or iterating until the stack is not empty. So inside the stack, what I'm doing is popping the last element in the stack or list, and I'm assigning it to node. Now we know that we want to first print out the root node. So what I'm doing is simply getting the value in the root node and appending it to answer. That's the list that contains the elements in order. So we want to first get the root node. So that's what I'm doing here. After I have appended the root node to our answer, I have two conditionals. The first conditional is to check if there is right subtree. If there is right subtree, I'm appending the right subtree to the stack. And after I appended the right subtree to the stack, I'm checking if there is any left subtree. If there is, then I'm again appending the left subtree to the stack. And now you might be confused here. Why am I appending the right subtree first instead of left? Because in pre-order traversal, what we want to do is first get the root node, then get the left, and then only get the right element. But we are doing exactly opposite here. The reason is that once I append the right and left subtrees, I'm again coming back to this piece of code, which pops, which means it looks at the last element, and the last element was when we appended the left subtree, not the right subtree, the left subtree. So we are basically popping the left subtree here inside the node, and then assigning or basically finding the root value at the left subtree and assigning it to answer, not the right one. And that's the reason why the order in which I'm checking and appending the subtree is in the reverse order. So if you look at this example, that might make it even more clear. So first of all, the root node is 1, so I'm appending. So let me just write a list here. Sorry. Let me just get back. So the first, our answer would first have value 1, because we're just popping it and then appending the value, a root node value, to the answer, which is 1. And then in the stack, initially we had one, but we then searched if there is a right subtree, and there is, and then I have to add right subtree root node, which is 3, and then I'm checking if there is a left subtree, which and there exists, which is 2, so I'm adding 2 here, right? And the next time I iterate this loop, I am popping the value to the node. Now node here becomes 2, and in the stack, since I'm popping, I have to remove the last node. 2 is the left subtree, and then what we are doing is basically finding the value at the node, which is 2, and we're appending 2 to our answer, which means the second element is going to be 2. And that's why we have the reversed order, right? So after doing that, I'm again checking if there is left and right and left subtree. There is, and I'm again appending the stack with the values here. So it's going to be something like 5 and 4, right and left, right? And then again I'm popping the value at 4, which means I have to add 4 in our answer, which makes sense if you look at the output. 1, 2, 4, that's the order we are looking at. See, it works. So that's why this iterative method should work. Let me just check. If I run this, it should pass all the test cases. It does, and I can submit it, and it should pass all the test cases as well. So yeah, it works just fine, and that's the solution. In the next video, I'm going to be working, or we'll be looking into post-order traversal, which is more challenging. But yeah, until then, bye bye. Thank you.